So again, I said I'm not going to do the ones that we covered in class, like B, because that is a substitution and you guys can substitute that, okay? So we will, we can definitely do, let's go ahead and do A. So 2A has 8K minus 9 divided by 3. And then it tells you K is equal to 7/8. So this is a substitution problem. I'm going to take my value of 7/8 and I'm going to substitute that into where I see the variable of K. So I'm going to rewrite my expression as 8 times 7/8. Remember, if you see a coefficient with the variable, that's a product, that's a multiplication term. Minus 9 divided by 3. Now we can evaluate this using order of operations. So do I see any parentheses? I do, but those parentheses technically count as what? Multiplication, all right? So not really any parentheses, not really any exponents, but I do have multiplication. So remember I told you multiplication and division, we treat those as pairs. So when we read the sentence, our expression, we read left to right. So whichever multiplication or division comes first is the one that we evaluate. So 8 times 7/8, remember 8 times 7, and then divide that by 8, we should get 7. So again, I'll show you how to do that. So 8 times 7, you get 8, well, I'll show you. 8 over 1 times 7 over 8. 8 times 7 is 56. Over 8, because 1 times 8 is 8. 56 divided by 8 gives me 7. And I'm going to rewrite my expression, so minus 9 divided by 3. So hopefully everybody got to this point. So we just finished with multiplication. Do I have any division? I do. So right here I'm going to evaluate 9 divided by 3 to get 3. And then 7 minus 3 is 4. All right? So that's pretty simple. Just make sure you guys show your work and go step by step in your expression as you substitute to evaluate, right? So we're going to move on from 2. Basically, that's the same concept for B and C as well. So let's go to 3. 3A we did in class, but I'm just going to make sure, actually we did 3A, B, and C in class. So I'll just reiterate. If you see variables or numbers being multiplied repeatedly and it's the same base, meaning it's the same number being multiplied, I can write this in exponential form as m to the 4th. This is not the same thing as 4m, okay? If I told you that m equals 2, I'll show you how that's not the same. If I went ahead and substituted, this would be 2 times 2 times 2 times 2. This would be 4 times 2. So now if you guys evaluated this you would get 16. This you would get 8. Not the same value, right? So just make sure when you have an exponent, you're actually multiplying that base 4 times based off your exponent, okay? So that's the same concept for B and C. So let's move on to 4. It says use the distributive property to write an equivalent expression for each expression. So equivalent means equal, right? So if I start with 3 parentheses 3c plus d, we're working off 4a right now, I want to go ahead and use the distributive property. So my GCF, remember we said that was called our GCF, I want to distribute that to 3c, right? And I want to distribute that to positive d. Now by distribute we mean multiply, so 3 times 3c gives me 9c. 3 times positive d gives me positive 3d, not d cubed. This is saying I'm multiplying it to d. So your expression that's equivalent would be 9c plus 3d, okay? So let us see okay, so let's do 4b because I think I did get some people who are confused on this, and it's the same thing. So 11x plus 5 times 2x plus 4. Now, don't get overwhelmed because this is in front. this is still your coefficient, so you want to distribute this to what's inside the parentheses, right? This looks familiar, so let's go ahead and simplify. All right, so I'm going to rewrite my expression. 5 times 2x gives me what? Positive 10x. 5 times positive 4 gives me positive 20. Now, do you guys notice that I have like terms? I do. I have x's and I have a constant, right? So I can combine 11x and positive 10x, but not positive 20. Okay, you guys will make me cry if you add 20 to your x's, okay? Those are not like terms. So once you get through the hard part, which is not too tough, just combine your like terms and you'll find your simplified expression. So 11x plus 10x gives me 21x plus my constant would be 21x plus 20. Simple? Okay, so I'm going to move on. Now, 5 says, are these two expressions equivalent, right? Yes or no, and why? So let's look at the first one. Actually, let's look at 5C, because I believe we went over A and B in class, okay? So 5C says 5 times 6A plus 4B, and then is that equal to 20B plus 30A? Okay, so I'm going to distribute 5 because I want to see the simplified version. So 5 times 6A and then 5 times positive 4B. So 5 times 6A gives me 30A. 5 times positive 4B gives me positive 20B. Now, a lot of you are saying, I hope you're not saying no, because 30A comes first and 30A comes last here. These are actually equal to each other. So just because 30A comes first doesn't make this expression not equal to that expression. So this is commutative property. If I flip these, it means the same thing. This 30A is a positive 30A. Just because you don't see positive here doesn't mean it's not positive. We talked about this. This is a positive 20B, exactly like this positive 20B, right? So these mean the same thing, same exact expression, okay? So there is 5, that was 5C. So now we can move on. So guys, 5A and B are done the same way. So if you can get one part, try the 5A and B, and you should be successful, okay? So 6A, this is an order of operations problem. So make sure you guys are evaluating step by step with this. So I'll go ahead and write this out up here. 35 divided by 7 plus 3 to the 4th times 24 divided by 6 squared. Now, using PEMDAS, you guys know PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Do I have any parentheses? Yes, I do. So I'm going to go ahead and do left to right, starting with my parentheses. I'm going to evaluate 35 divided by 7, and I'm going to rewrite my whole expression. I'm not even going to worry about evaluating anything else. Even if I see parentheses, I will evaluate that next. So 35 divided by 7 gives me 5, plus 3 to the 4th, bracket, 24 divided by 6 squared. Now, am I done with evaluating my parentheses? No, I am not, because I still have some parentheses to evaluate. So I'm going to rewrite my expression. Now I'm going to evaluate 24 divided by 6, which gives me 4. Now I'm done with my parentheses. Now I'm going to move on to exponents. Do I have exponents? Yes, I do. So I'm going to go ahead and rewrite until I can no longer rewrite. So 3 to the 4th, guys, that's 3 times 3 times 3 times 3. So that you guys should have calculated that to get 81. Times, now 4 squared, I'm going to go ahead and do this as well. 4 squared gives me 4 times 4, right? The expanded form of 4 squared is 4 times 4. So 4 times 4 is 16. Okay? Now I'm to a place where I just evaluated exponents. Now I want to see if I have any multiplication. So I'm not quite done yet because I still have a bracket here. I simplified my bracket, and this we kind of consider like parentheses because I can't multiply 16 with 81 because it's in my bracket. Brackets are sort of like parentheses. So these parentheses basically mean 5, okay? This was just left over from 35 divided by 7. So 5 plus 81 gives me 86 times 16. So I should evaluate this, and I get, because multiplication is my last step, 1,376. And I don't expect you, I mean, that's simple math, but I don't expect you guys to work that out. You will have calculators tomorrow, okay? Next. So I want you guys to look at, let's see. Let's look at 7. And you guys can pause the video and see if you could do it on your own and then check. So hopefully you guys pause the video and then you're just checking your work. Whoops, my mistake. R plus 3. Now, the way I want to do this, number 7 says simplify the expression. So automatically, I notice I have distributive property here. So I need to simplify both these chunks of information, all right? So I'm going to distribute 8 to 2r, and I get 16r. I want to distribute 8 to positive 3 as well, and I get positive 24. Now I'm going to do the same thing here. Plus, distribute 2 to positive r, I get 2r. Distribute 2 to positive 3, I get positive 6. Now, does this look like an expression that we can combine like terms? It sure does. So r, I have another r here, it's positive 2r. Remember guys, when you're circling your terms, this is what we struggled with on the ticket out the door, is knowing what kind of term that is. This is a positive 2r. So when I see 16r, I'm going to add that to 2r because of this sign. So 16r plus 2r gives me 18r. I also have my constants here. So 24 plus 6 gives me positive 30. So hopefully you guys feel pretty good about that. It's just simple. Make sure you're working slowly. So number 8 and number 9 we did in class. So you guys shouldn't have too many questions about that because we did discuss about that. Same thing with 10a and b. We discussed about both of those in class. You guys know what the coefficient is. So for example, if we're looking at 10b, 5x plus 3. Now, we need to simplify this, so this is distributive property. We're going to distribute 5 to x and 5 to positive 3. So I get 5x plus 15. So I have two terms. Remember guys, the definition of a term is that it's separated by an addition or a subtraction sign. So I have 5x and positive 15. All right, so 5x, 5 is actually my coefficient, and 15 is my constant. All right, so let's keep going. Number 11, we did that one in class as well. You guys know that perimeter is adding all the sides. So if you need to rewrite your expression just like this, that works as well. So basically you see that I just rewrote on both sides the equivalent side length. And then at the bottom, I just rewrote 2x plus 4 plus 2x plus 4, because I have two sides, plus x plus 1 plus x plus 1. And then I went ahead and I combined my like terms to get 6x plus 10. All right. Same thing with 12. 12 is a area problem. So area, guys, this is actually something you learned in elementary school, and the formula for area is length times width. So when I look at a rectangle like this, I see that my length is actually 6, and my width is when I add these two terms together. So that's why 6 is on the outside in the parentheses, this forms a distributive problem. So 2 plus 4x, right? Because when I distribute 6, which is my length, times my width to 2, I get 12. Distribute 6 to positive 4x, I get positive 24x. So this is length times my width, and I just added my width together, okay? So let's go to the back, because I know you guys had some questions on the back that we briefly touched on. So I will be a little bit more thorough with the back. So part 1 says factor using GCF and distributive property. Guys, you know GCF, you know how to find the GCF, and you know distributive property. So if I give you, if we work out the example, 24x plus 16, I'm going to take my two numbers that I look at initially. I'm going to take my coefficient and my constant, and I'm going to find the GCF between these two using my ladder method. Remember, we said this area is always reserved for a prime number, so I'm going to use 2. 2 goes into 24, 12 times. 2 goes into 16, 8 times. I want to keep going because 12 and 8 have an additional prime number that can go into both of these. So 2 goes into 12, 6 times. 2 goes into 8, 4 times. Now, I don't stop there because neither of these are prime, and I can go ahead and distribute or factor out another prime as well. 2 goes into 6, 3 times, and 2 goes into 4 twice. I've hit 2 primes. I can stop right there. You guys remember, this should be a review. 2 times 2, when we take these numbers, we're going to multiply them together to find the GCF. So 2 times 2 is 4, times 2 is 8. So I'm going to come down here, and I'm going to start to form my distributive property. So 8, and then 3 goes in my parentheses along with 2. But you need to go back to your expression and look at what that 24 represented. That represented the coefficient of x. So this 3 is actually 3x since we simplified 24. And then my 2, 16 was a constant, so that's okay. It's a positive 16, so that is a positive 2. Now, this is your distributive property expression. If you guys want to check if you're right, go ahead and distribute. 8 times 3x gives me 24x. 8 times positive 2 gives me positive 16. Does this expression match what we started with? It sure does. So my answer would be 8 times 3x plus 4. All right? So that's pretty simple. You follow the same pattern just like we did for all those examples. So just make sure that you guys are adding those variables when you go back to create your expression, your distributive property expression. So let's look at part 2. It says simplify using the distributive property. So let's look at our example. So our example, I hope you guys didn't get too confused. They just did step by step. So let's look. So right here they had 8 times 2a plus 6. You guys know that when we look at this, we're just going to go ahead and distribute 8 to positive 2a and 8 to positive 3. So basically right here, guys, they're writing what you just